my lovely students. Hello, my atoms. A very warm welcome to all of you. Hope all of you are doing absolutely awesome. My name is Anubha Gaur, your chemistry master teacher at Vedantu. And students, I hope you're very happy and excited, specifically talking about ICSE students, because we are trying our level best to give you all the informations about all the chapters of chemistry, mathematics, social science, and each and everything I'm talking about. So, students, today in this session, I'm going to teach you metallurgy, whatever is going to come in your syllabus, going to come in your exam this year, that is 2021. Okay. So let's do the complete chapter and it will be sorted, it will be done, right? Are you with me? So give me a quick thumbs up. We'll revise metallurgy, all the topic according to the reduced syllabus. Yeah? Okay. Don't forget to hit the like button, share it among your friends, and definitely subscribe if you're new, because if you do so, you will get each and every notification and can attend all the possible sessions, can revise everything, and definitely that will help to boost your score and to boost your confidence as well. All right. So I hope after this session there'll be not even a single doubt that will be there. So let's start it right away. Thumbs up, high five, right now. Okay, so the very first thing that you should know is very much simple thing, that how do metals occur in nature, and you know it very well. It's not like that you will see the earth crust and you will be finding each and every metal like the same way. Yeah, we have to come across with so much of processes, and then in the final way we get our metal. So most of the metals actually occurred in the combined state. Combined means that's there with some of the oxygen, maybe carbonates, maybe sulfides, maybe chlorides and all. So they combine with the other substances, and in general they are there in the form of minerals and ore in nature. What exactly is mineral and ore? Don't worry, I'm going to tell you only. And just understand this occurrence of metal depends on the reactivity series also, like how much reactive your given substance is. If that's very much reactive, that will be definitely there in the combined form. But if that's least reactive, that can be there in the free form. Like the only metal with some impurities, we can get rid of impurities and get our pure metal. Okay. So if I talk about my sodium, my potassium, my aluminium, they are there in the nature in the combined form, some in the chlorides form, some in the carbonates form, very much reactive. When it comes to moderate reactive metal, they generally exist in the form of sulfide and carbonate ore. Some less reactive metal, generally sulfide ore, and as I told you, least reactive in the free form. So there'll be different methods to get rid of those oxygen, those chlorides, those carbonates and sulfides, and finally get a free metal from the same. There'll be entire process that I'm going to tell you, but according to the syllabus that you should be knowing. Okay. So as I told you, if I talk about potassium, sodium, calcium, magnesium, aluminium, these are the reactive metal. This is the reactivity series. And when we move down in the reactivity series, reactivity decreases. And here reactivity simply means their tendency to lose electron so that they can combine easily with the other substance. So when I say reactivity is decreasing, that means their tendency to lose electron decreases. Tendency to lose electron decreases, and their tendency to combine and react with the other substance definitely get decreases. Okay, but you can conclude one more thing, that means tendency somehow to gain electron, if that will be needed, if they are in the form of cation, they can take electron, and to take electron, to gain electron, the tendency will be increasing down the series. Yeah, the best method to get our pure metal from these highly reactive metal is electrolysis. Moderate reactive metal reduction using carbon. First, we'll convert them into oxide ore, and finally, with the help of reducing agent, that is my carbon in the form of coke, I'm going to get my metal. And for the less reactive metal, when I talk about silver as gold, that is like least reactive metal, they found in the native state, means free state, and only will be needing some purification method to be come across. Okay, so this is what we'll do. When I talk about sodium and potassium, so it's like how different metal is going to occur. We'll first of all talk about the highly reactive. Sodium and potassium occur in their nature in the form of chloride. How come? Sodium chloride, potassium chloride. So alkali metals are there in general. They'll be there in the seawater and in the form of chlorides. When I talk about calcium and magnesium, a bit less reactive in the form of carbonate, like calcium carbonate, magnesium carbonate in the nature, in the earth crust I'm talking about. Then comes aluminium. Aluminium generally there in the form of aluminium oxide. Then comes zinc. Zinc is there in the form of sulfide and carbonate. Silver in the form of sulfide. Silver is there in the nature generally in the free form as well as in the sulfide form. So as copper in the free form as in the sulfide form as well, because these are some less reactive metals. Okay, we did that part. So insoluble ores are found as rocks. When I talk about the ore like pyrites, pyrites are the ore of like FeS2. When these are the ore, suppose that's there with copper, so that's a kind of a copper ore, pyrite ore. So they're in the nature in the form of insoluble ore. And insoluble means that's not going to be dissolved in water. So how they'll exist? They'll exist in the form of ores. There is some list, just like we have some gypsum, halite and all. You do not need to understand that in very much detail. Not going to come into exam, but some basics you should know. And soluble ones, as I told you, are my alkali metals, chlorides, that is my sodium chloride, potassium chloride. They are the ones that we generally found in seawater. These are the information how metal compounds are there in the nature. When I talk about metal with less reactivity, least reactivity, we did that part that they exist in the free state, like gold and platinum and silver, and sometime copper also. Okay. So I'm going to tell you right now some of the ore. What exactly is ore? Ore are those minerals from which metals can be extracted conveniently and beneficially, like low cost process with the help of which I can get my ore. Economical process as well and convenient also. Okay. And what exactly is mineral that I'm talking about? In which my metal is there and from which I can extract my metal, and they're in the nature as one of the form of resources. It's like resources. Minerals are my resources. Okay. So potassium and magnesium exist in the nature in this main ore called as carnallite, and the formula is it's more of like a double salt. Potassium chloride, magnesium chloride with 6 molecule of water. It's a double salt. Okay. When I talk about sodium, exists in the nature in form of rock salt, slightly pinkish color due to impurities of other substances there, and that is sodium chloride. I'm going to tell the name of the ore and their formulas too. Aluminium in the two are bauxite and cryolite. Bauxite is very common ore that I'm going to teach very soon because that's there in your syllabus and going to come into exam for sure. Yeah. So that will going to exist in the form of aluminium oxide with 2 molecule of water. This is bauxite ore. Cryolite is Na3Al(F6), sodium aluminium fluoride. Do remember this name because we are going to use that one also. Calcium we already discussed in the form of carbonate, and very famous example is limestone, that's calcium carbonate. Zinc in the form I already told you, sulfide and carbonate. Zinc sulfide is the name of the ore is zinc blend. Calamine, you might have seen the lactocalamine lotion. Why that is called as lactocalamine? Calamine totally means here that that is having zinc carbonate in it. I'm having that solution. I've read the ingredients part and it was written zinc carbonate is used because that's a mild base and that can kill some of the bacteria that create some amount of a bit of acid and then create infection to our skin. So we use that. Okay. Iron, iron in the form of hematite, very famous one from which we can get our pure iron, and that is Fe2O3. Fe2O3 is hematite. Lead we have in the nature in the form of ore called as galena, and the formula is PbS, lead sulfide. Copper, I already told you this ore of copper, that is copper pyrites. The formula is CuFeS2. This is pyrite, pyrite part. Copper FeS2, that's my pyrite, copper pyrite, and also called as fool's gold. Isn't it amazing? This is called as fool's gold because its appearance is more of like a gold. Okay. And cinnabar, look at it. How beautiful this is. Cinnabar is the ore of mercury, and that is mercury sulfide. Yes. And silver. This is some funny name. Argentite, this name is a bit common. Argentite comes from Argentinum, which is silver's Latin name. Argentite is silver sulfide, and horn silver. Isn't it funny? Horn silver is silver chloride. Okay, so I told you my copper and silver exist in the nature in the free form as well as combined form. Now, the best part is there'll be some impurities in that ore, and then in that ore we have oxide, carbonate, sulfide and all. We need to get rid of it. Even after that, sometimes we don't get a pure metal and we need to purify it further. So what's the entire process is known as? That is called as metallurgy. So the metallurgy is the process where we are going to extract the metal, we are going to get rid of the impurities, extract the metal and then purify it. This entire process is called as metallurgy to get my pure metal. All right? And metallurgy deals with the production as well as purification of metals. And then finally we can prepare alloys from the same as well. All right? I told you what exactly is mineral. These are a kind of a resources in which metal is there along with some of the impurities with some matter such as soil, limestone, rock and all. Okay, these are the minerals and we are going to consider only those minerals as ores. Ores is a part of mineral only. Ores are those minerals from which metal can be extracted conveniently, economically, beneficially and all. Yeah. So what's this term? We are going to talk about all the general terms that we use in extraction and we should know it. One is gangue, which is also called as metric. So don't get confused in between these two terms. Gangue or metrics are nothing but earthy impurities, just like silica. Silica is like SiO2, the main content of your sand. Mud associated and sometime your limestone also. These particles act as impurity with my ore, so called as gangue and matrix, and we need to get rid of those impurities. If we get rid of those impurities, we'll get a concentrated ore with high content of metal. Okay, so ore part is also clear, super duper clear. What exactly is flux? That is great thing. That is something that you should know. Flux is that substance that we're going to add in the furnace to remove the gangue particle. So gangue particle, those impurities, according to the nature of gangue particle, we are going to get flux particle and going to add it. Like depending upon the nature. If gangue particle is acidic, those impurities are acidic like silicon dioxide. We can add flux like basic like calcium carbonate. Okay, so these are some chemicals only, and when we put it in furnace they'll combine and give a molten slag. So the slag that we are going to get is the mixture of the same. When they'll react, give a molten substance different from your metal and going to separate it from the metal, and we can separate it and we'll get our molten metal in that furnace separately. Okay, so these are the term you should know. Now you know flux, you know gangue, which is also called as matrix, you know slag also, right? And see this, the equation is there in the front of you. If gangue particle is silica, I mixed with flux calcium carbonate, they combine together to give calcium silicate and CO2 gas. Gas will evaporate out, molten slag you will get. And I'll show you the diagram also how that is going to separate, because that process is called as smelting. Two type of smelting processes there. One where the process of reducing the oxide ore, reducing the oxide ore, I'm having, suppose this is the oxide ore, Fe2O3, iron oxide ore, hematite ore. And oxide ore we can reduce with the help of a proper reducing agent like carbon in the form of coke, and we do it in a furnace. We'll heat it. So this process is called as smelting, like reducing my oxide ore. Okay, and then we get our molten metal in that furnace, and also removing the gangue with the help of an appropriate flux added with the ore. So smelting is also called as the process of removing the gangue particle with the help of a appropriate flux added so that they'll give you the slag, right? I'll show you with this process. See that here what we are doing, we have a blast furnace. We added my ore, suppose iron oxide. We added coke acting as reducing agent called a smelting process, and limestone were also there, suppose acting as my impurity, my gangue particle. So what slag particle I'm going to get? I'll choose my flux accordingly. Suppose I've added silica, SiO2, because that is acidic. If my gangue particle is basic, so they'll combine in the furnace, they'll give you molten slag, and that will be separated because of the difference in the density, and the molten metal will be out because carbon is going to reduce my metal oxide, and that will be separated as well. So reduces the oxide ore to metal in the molten condition. You got the process of smelting? Two way we can explain that. So do remember that. So all the process we are going to involve in the extraction is what? We are going to have the ore, we are going to crush it, called as pulverization. We'll get that powdered ore. and then that pulverized ore we are going to concentrate it. Like we'll get rid of the impurities as much as possible to get a ore with highly concentrated concentration amount of metal. Okay, and for that we'll do different process. When we get the concentrated ore, depending upon the ore of the metal, we'll be doing some of the process like roasting, calcination, that finally give my metal oxide. Roasting is a process where I'll be having my sulfide ore and I'm going to heat it with the access of oxygen, so that sulfur will go with oxygen in form of SO2 and I'll be left with metal oxide. Calcination, heating my metal or generally metal carbonate in the absence of oxygen, and when you heat it, carbonate will give CO2 gas that I told you so many times, and you will be left with metal oxide. So these are the process so that we can have metal oxide, and then you can use a proper whatever is the reducing agent. You can introduce carbon, sometime aluminium also, so that you will get your metal. Okay, and when you get your metal, we sometimes we use electrolysis also, like highly reactive metal ore. We can get my metal with the process of electrolysis because that's the best method to get the pure metal. When we get our metal, sometimes it still can contain impurities of other metal, and from the impure metal we are going to refine it, electro refining, for the purification. Generally the method uses a kind of electrolysis only, and we'll get our pure metal. So this is more of like a summary that we generally do to get my pure metal. Is it super duper clear? So this is some basic that you should know about ores, minerals and all. Right now, I'm going to start the process of aluminium, extraction of aluminium, which is the most important part of your syllabus. Yeah. But before that, why not let me just tell you in short about this platform called as Vedantu as well, where you can come and attend all the classes, gain 100% knowledge, and can boost your score, can boost your knowledge as well, and can attend unlimited live classes. Fun quizzes will be there, fun classes, and you'll be able to learn so many things, and the quiz level will be good as well. And to make sure that you're learning everything, there'll be active learning, you'll be participating, we'll get your data that how much of you got it and all, how many of you got it and all, and we can respond accordingly. Okay, and you will be able to have a competition with the students throughout the world. The best part, you will be able to see all the interactive replay, like where you can participate in the quiz too. So interactive replay means that will be not like boring session that you're just watching it, but your name can come to leaderboard according to your response. You'll get all the handwritten notes also of all the master teachers with their own feedback, what's most important topic, where you need to pay more and more attention. All of your doubts will also be solved with the help of class, with the help of master teachers and a team of class teachers, so that no doubt remain unanswered and you'll get everything. The best part is some of the free courses that will be a part of the same. 5,000 plus chapter based courses. Crash courses is the best attraction right now because exams are near. With the help of crash courses, you can revise everything here. Each and every topic you will be able to revise with most important questions and so much of practice. And here less is more, because students, if you'll apply for the same, if you'll enroll for the same with the code AGE Pro, this will give you a massive discount. So there is a link in the description box pinned by Vedantu 19 channel, the very first message of 19 channel. When you open it, get pro classes, you will get a link. Just click on it, select ICSE 10th class and target 2021. And when you apply AGE Pro code, you will get a very good discount which was not there before. So the price of Pro from 2500 will drop to 2000 for 1 month course. And it's like having a session in as low as 10 rupees, because you can have as many number of classes as you want. If you go for a longer long term plan, like till June, so that when your exams are over, as exams are getting postponed, you will be able to revise each and everything in detail, in depth, and can make sure that your exams are going to go fantastically awesome. And for that, you just have to pay 6,000 for almost 5 months, and it's like giving you a session in as low as 6 rupees. So do not forget to enroll for the same. It will be a good investment for you. You will learn so much. Your personality will be enhanced as well. So come in, get all the classes. Don't forget to apply the code AGE Pro. Okay, AGE Pro. Let's move to our new topic, that is extraction of aluminium. how we'll get our pure aluminium. So let's talk about its process one by one. So the very first thing, how aluminium is going to exist in the earth crust. We know that. I already told you. Generally in the form of bauxite ore. What is bauxite ore? That is hydrated aluminium oxide, which is aluminium oxide with two molecular water. That's how that existed in the nature. Hydrated salt, that doesn't mean it's making it wet. That's water of crystallization, making a part of its structure. Cryolite, that is sodium aluminium fluoride, very much common and very much important too. Corundum, that is anhydrous aluminium oxide. Okay, that's comparatively less in nature. This is comparatively more, and with the help of which we can extract my aluminium conveniently, and almost 60% aluminium is there in the same. So we are going to use that generally. Aluminium symbol is Al. Atomic mass is 27U. That means it's 27 times heavier than 1 by 12th part of mass of a C12 atom. That's a relative mass. Silvery white metal, its atomic number is 13. We know that mass is double plus 1. Specific gravity 2.2 means that's 2.2 times heavier than my hydrogen gas. That's what we generally take as a consideration. Sometime with water also, like how much heavy that is as compared to water, we can say that. Valency is 3 because the configuration is 2 at 3. It can lose 3 electron being metal and show a valency of 3. Period 3 because total number of shells are 3. So that is going to belong to third horizontal row. Group 13 because when valence electron is more than 2, you have to add 10 to decide the group number. That's the vertical column where exactly it's placed in the periodic table. So 13th group and third row. Okay, this is easy peasy. Now, who discovered aluminium in the very starting? That was arrested in 1825. And most abundant metal in the earth crust, then we got to know that. And the best part is, not so best part, that it was very expensive and very starting, more than even gold. Then what exactly had happened that now aluminium is so cheap? Because Hall and Heroult scientists, two scientists, they gave us a commercial process which is very, very cheap. And that's how we are getting it so cheap. Okay. So it's a kind of a reactive metal, so it does not exist in the free form in nature, but exists in the form of aluminium oxide. Yes, aluminium oxide. Generally bauxite ore with two molecular water. So we'll talk about that process in detail, okay? Hall and Heroult in 1885 developed the process of extraction of aluminium. Extraction. I'm not talking about right now about the removing of gangue particle concentration of ore. That was done by a different scientist and that process is called as Bayer's process. Yeah. So let's do that. We have our bauxite ore, that's aluminium oxide with two molecular water. First of all, let's get rid of the impurities and let's understand the extraction process. Purification refining method is not part of your syllabus in this year. That's Hoops process. But if you still want to understand that part, I had covered that in the previous video on Hindi and English channel. You can see those videos also. Okay, 60% aluminium. Let's talk about Bayer's process right now. What's Bayer's process? I think I've told you. What exactly is that? Students, class will be very much fun if you will not be just sitting and listening to me, but commenting also. You can comment in the comment section and definitely in the chat section right now. Your doubts, how exactly the session is going, you're getting everything, and whatever ma'am asks, just reply to them as well. Okay? Bayer's process is what? First of all, we'll get that bauxite ore and we're going to grind it finally, pulverization, right? And then we are going to heat it. Because when you heat it, if there is some volatile impurities, that will what? That will convert to vapors and go away. So now all the volatile impurities are gone. Now, after that, what will we do? We'll take that part and we'll heat that. We'll take that bauxite and we heat that by putting them into concentrated caustic soda. Caustic soda is my sodium hydroxide. I'm having my sodium hydroxide, concentrated sodium hydroxide. I'm going to put it and I'm going to heat it for 2 to 8 hours at 140 to 150 degrees Celsius. The reason is this is my what kind of ore? This is my amphoteric ore. Amphoteric substance in nature, dual behavior. Ampho means amphi, dual behavior. It can act as acid and base accordingly. If I put it into a base, that can act as an acid and can give salt and water. So when they combine, we get a salt called as sodium aluminate with water. As it's a salt that will dissolve in the water, but whatever the impurity was there in the bauxite ore, that will settle down insoluble impurities in form of red mud, and we can get rid of the same. All right. So insoluble impurities, red mud, that we can extract out now. And now I'm having salt and water, my sodium aluminate mixture with water. Now I'm going to dilute it, and then around 250 degrees Celsius temperature, I'm going to cool it also. Sodium aluminate, I'm going to put water. I'm going to put more and more water to dilute it and then cool down also a bit. So in this process, NaOH I'm going to get back. This is HOH. Na with OH, NaOH is a back. So this is called as a reagent. What exactly is a reagent? We used in the reaction, that participate in the reaction and finally comes back also, and we can extract that. So I'm going to have NaOH back, and my aluminium react with some of the OH to give aluminium hydroxide gelatinous white precipitate. So my precipitate will come out gelatinous white precipitate. Gelatinous white precipitate settles down, and NaOH is there. If there are still some impurities, that is there in the NaOH. Soluble impurities, it's still there, that's in the NaOH. And aluminium hydroxide precipitate settles down. I'm going to filter it. After filtering, what I'm going to do it, I'm going to put some water to wash it and then dry it. Okay. So now when I'm having this aluminium hydroxide precipitate, dried form, I'm going to heat it at around 1000 degrees Celsius. Because when you heat it, it will decompose to give my alumina and my water. Water will be evaporated. Water will be evaporated, and we are left with alumina. And that's something that we needed, because that's having a pure form from which aluminium can be extracted, like 99.8%. Isn't it like great thing? So this process is called as Bayer's process to get my pure alumina from my bauxite ore, because from this alumina we can reduce it to get our aluminium, which was done by Hall and Heroult. Okay, so aluminium oxide, it's not that easy that I'm having aluminium oxide. I'm going to use a normal reducing agent like carbon that can reduce my aluminium. Not at all. First of all, carbon is not that reactive to displace aluminium. Also, aluminium is having a very high affinity towards oxygen and will not leave it easily. So the best method will be electrolysis, because electrolysis, what will we do? We'll pass electricity, decomposition of ions, and can occur with the chemical change to get my metal and then the non-metal on respective electron. That's what we are going to do. Okay, students? And how will we do that? Let's understand that this is the tank we are going to use. That's called as electrolytic tank, and that we are going to use a steel container only, because that's not going to affect. Now we use generally cathode and anode in electrolysis. Cathode is the negative terminal. Why? Cathode attract cation. Cathode, cat, attract cation means that attract positive. So this is negative. How we know that cation is positive? A small trick. I know that you know it, your ICSE students though. Cat has pause. Means cation is positive. So anion is negative. Annie is a very famous character, Annie Frank, if you know. There's a story also in English literature. Yeah, Annie. So anion is negative, so that there'll be no confusion in the same. So cathode attract cation, it attract positive. So that's a negatively charged metal rod or negatively charged electrode that's connected to the battery. So cathode, what we have taken, gas lining. We have taken our steel container, and carbon gas lining we put. Like carbon in the form of graphite is a good conductor of electricity. So we are going to take the graphite and then we are going to put the lining in the gaseous form to here. And that's a bit having a steep here, so that the pure aluminium we are going to get can come out in the molten form. Why here? Because we are considering this as cathode that attract cation, and in aluminium oxide, my aluminium will be there in the cation form, oxide in the anion form. So these cation will move towards cathode, that is here in the molten form, and come out. Okay, anode we are taking here. Anode is positively terminal. Okay, this is my anode, positive terminal carbon rod. That is my graphite rod only that we have taken. And here we have taken alumina. That's Al2O3. But the sad part is alumina is not a conductor of electricity, non-electrolyte. Then that creates a problem. What to do? We can't do electrolysis. We are going to put two substances into the same, cryolite and fluorspar. Now, what exactly is this? Cryolite, I already told you, Na3Al6, sodium aluminium fluoride, and fluorspar is my calcium fluoride. So what they'll do, they'll help my aluminium oxide. They're acting as a solvent so that my aluminium oxide can dissolve in the same, also reducing its molten temperature. Aluminium oxide's melting point is 2050 degrees Celsius. So now it can't conduct electricity at all due to very high melting point. This mixture can dissolve the melting point to 950 degrees Celsius. So fusion point of this mixture is 950 degrees Celsius less. So now ions can be totally free and can move towards respective cathode and anode. In this mixture, we are going to sprinkle some coke powder also, so that when the temperature was maintained to 950 degrees Celsius, it will be maintained and the heat radiation will not be lost. Also, oxide ion is that negative ion. When they move towards my carbon dioxide gas is going to generate at some time due to heat content that can catch fire also. So putting my sprinkled coke is protecting them from catching fire also. Okay, they are not getting air from the outside also. Yeah, so let's understand that. Regular tank we have taken lined with gas carbon. Now, what are the ions we are going to have in this? Al, Na3Al6. I'm going to have cation, that is my aluminium ion, my sodium ion, and my calcium ion. This is from fluorspar, this is from cryolite, and this is from my alumina. Now, I already told you the reactivity series, that when we move in the reactivity series, their tendency to gain electron increases. Their tendency to lose electron decreases, so their tendency to gain electron increases. So when I talk about the reactivity series, first comes sodium, then calcium, and in the last aluminium. Means aluminium is less electropositive, so has maximum tendency to gain electron. Why it need electron? So that it can get rid of its charge and can be there in the free metal form. So aluminium oxide will move towards my cathode and will gain electron and give you aluminium metal. Now, when I talk about anions, we are having oxide ion and we are having fluoride ion, right? And now they want to get rid of their negative charge. They want to lose electron so that they'll give you free non-metal. Now, when we talk about oxygen and fluorine, we know that fluorine is more electronegative and more tendency to gain electron. So can we say oxygen is less electronegative? So more tendency to lose electron? Yeah. So oxygen in the form of oxide ion will move towards these anode. And what will happen? This carbon rod, and when oxide ions were going towards these carbon rod, graphite rod, oxide ions will lose electron to give oxygen gas. Now, oxygen gas react with these carbon electrode called as anode, and carbon when react to oxygen first give carbon monoxide and finally carbon dioxide. So these carbon rods reacting with oxygen to give carbon dioxide gas and vanishing out. So time to time we have to replace my electrodes, my anodes. Are you able to understand that? And we have to maintain a very low temperature, low voltage like 5 to 6 volt, so that the decomposition of molten cryolite will not occur. That's having Na3Al6 along with my alumina. Okay, so this can decompose at higher temperature. Okay, so this part is super duper clear. Cryolite will give what kind of ions? So as fluorspar and alumina, we already discussed that, and already discussed that aluminium will go towards cathode and give aluminium metal, and oxide will go towards anode and give oxygen gas. These were the reaction written here also. Why 2 aluminium? Because Al2O3. So 2 aluminium and 1 aluminium needs 3 electron. 2 aluminium will need 6 electron to give 2 aluminium metal atoms. Anode, I have 3 oxygen having 2 negative charge, so they need to lose 6 electron. 1 had 2 extra electron, 3 is having 6 extra electron. Minus means they are losing the 6 electron and give oxygen gas. 3 molecule of oxygen gas, as simple as that. We did talk about this also, that we need to replace these carbon rods, electrodes again and again, talking about anode. Okay, and by this process, we are going to get our aluminium at cathode from that steep in the molten form that's 99.8% pure, which is like a great thing. And if you still want to purify it, definitely electrolysis is possible by the hoops process, and that I told you I had covered that on Hindi channel also. You can see that process, but that's not a part of syllabus this year, so I am avoiding it because that's a one-shot video where we are talking about this year, whatever is going to come. All right. So awesome. This question can come. What's the use of cryolite and fluorspar? So reduce the molten temperature and acting as solvent also for the same, and making my alumina a conductor of electricity by reducing the molten temperature. This question can also come. What's the use of powdered coke? I already told you. You can download these notes also. I'll upload the file in the description box. You can you can download the PDF of this session. So entire flow chart is totally understandable. We'll be having bauxite ore. We'll do the concentration method to get rid of the impurity like gangue particles. After that, we'll do our Bayer's process to get our pure alumina. And then we'll do electrolysis, Heroult's process to get aluminium, which is a bit impure. To purify it, we are going to do electrolysis, Hoops process to get the pure aluminium. This is the entire process. I hope you understood it. Well done. Thumbs up. Can we reach to 300 likes? This is like a minimum target. Let's see that. I'll definitely see. Let's believe in your power, students. I know you can do it. Don't forget to share it to your friends so that they can also come see and appreciate all the efforts by all the master teachers here. Okay. Now we know we got aluminium, but what after that? What are its physical and chemical properties? How do it generally react? Let's talk about physical property. It's a silvery white metal. We know that light and very strong metal, and that also we know that that's why we are using it in making aluminium. In plane also airplanes, like we are taking its alloys. High tensile strength, it can bear so much of strain. That's why I'm telling you, aircrafts and all, we are using that. Okay, malleable and ductile, malleable making sheet. That's why we are having aluminium foil. I just packed my food in those aluminium foil only so that because we can make a sheet out of it, and so it can trap the heat also, so the food will remain hot for a longer time. Ductile, making wire. Nowadays we are using aluminium wire also in replace of copper wire, so this is something that you should know. It can be highly polished to produce a good luster, a good shine also, and that can be anodized to give a very attractive looks at times. But the best part is it becomes dull very soon, very easily, because that's a reactive metal that react with atmospheric oxygen and develop a protective layer of aluminium oxide over it, which is a good thing because it's not letting aluminium to react further and protecting it from corrosion also. That's a great thing. Okay. Melting point. Okay, don't get confused. I'm talking about aluminium here, not alumina. Aluminium melting point is 660 degrees Celsius and boiling point is 2050 degrees Celsius. Metals have high melting and boiling point. So that was the physical property part. What about the chemical properties, like how aluminium is going to react, being a highly reactive metal? Even if you don't do anything, even if that's there in the nature, that combined with the oxygen and gives an aluminium oxide layer, a bit dull layer, but that's acting as a protective layer, as I told you, because it won't let my aluminium metal to react with acid, to react with the water, to react with further oxygen also. So an impervious layer of aluminium oxide will be formed. But if you still want to react it with air like combustion, you can take aluminium powder. You will take aluminium powder and then that you're going to sprinkle it with air, then they can get burned, but you'll be needing high temperature like 800 degrees Celsius. Okay, and it's having nitrogen also. So it will give you a mixture of aluminium oxide and aluminium nitride. This is how it's burning with a bright light. Yeah. Now, what about water? As I told you, not going to react with the water because of its impervious layer of aluminium oxide. But with steam having such a high content of heat, it can react. So aluminium with steam, gaseous water, what it will give you, it's like a displacement reaction. Aluminium is going to displace hydrogen and taking its position. So I'm going to get aluminium oxide along with hydrogen gas. Aluminium oxide along with hydrogen gas. You get it, students? Wonderful. Now, how it react being a metal with acid and bases? So, because of its amphoteric property, dual behavior, it can react with acid as well as base, which is amazing. So, when I take base, my aluminium react with base in the same way my metal react with acid to produce salt and hydrogen, a kind of displacement. Like, let's do this reaction first, metal with acid. And this reaction is not very easy because first of all, the HCl that I'm going to take is not going to react at a faster rate, because of the layer of aluminium oxide. So first, some amount of HCl is used to get rid of this oxide layer because this is basic. This acid will combine with that to give a salt and water, and that will remove. I can, use that to get rid of that layer. The layer is gone. Now I'm having pure aluminium. Now it reacts with a faster rate with HCl to give aluminium chloride and hydrogen gas. Displacement. It will displace hydrogen being more reactive. So being amphoteric, it can react with the base in the same way. I'm going to take base with some amount of water, like a solution of base, and aluminium will displace to give a salt called as sodium aluminate with hydrogen gas. Sodium aluminate with hydrogen gas. This is not a displacement reaction. Please understand that. Both of the metal is coming here. Why sodium first being more reactive than aluminium? That's the reason. Okay, this part I told you, first low reaction and then reaction will increase. Because of that, we get rid of that aluminium oxide layer. Okay, this is awesome. Now, how it reacts with sulfuric acid? If you are taking diluted sulfuric acid, generally the reaction is again that is displacing. So you'll get metal, salt, and hydrogen. You got aluminium sulfate along with hydrogen gas. But if you take concentrated solution of sulfuric acid with metal, that act as my OA. OA means oxidizing agent because that is having oxygen content and can give to the other substance. So generally we were expecting the product that when metal react with acid, metal salt along with hydrogen gas. But what will happen? It combines to give aluminium sulfate and the hydrogen which I got was oxidized by this agent to give H2O and itself get reduced. What's an oxidizing agent? Oxidize the other substance and itself get reduced. So itself get reduced to give SO2 gas. Okay, because the content of oxygen get decreased. Loss of oxygen is reduction. So itself gets reduced and doing the oxidation of other substance. That's an important thing that you should know. So metal salt, water, and SO2, that's what the gas that you're getting. Now, when it comes to the acid called as nitric acid, that's like even more better oxidizing agent. If you take even in the diluted form also, that act as an oxidizing agent only, or even if you take in the concentrated nitric acid. But the very first thing is it's not going to attack the aluminium metal at first because of the same thing, because of the layer of aluminium oxide and not having the free aluminium. So this is something that you should know. And I told you already. So that should be there in your mind right now because it's kind of a revision and revision should be up to the par. Now this is metal. How that's going to react with non-metal. Metal with non-metal give you the ionic compound. Metal loses its electron to non-metal. Non-metal take it and metal get positive. Non-metal get negative. Opposite charge they'll combine with the electrostatic force of attraction to give ionic compound, also called as electrovalent compound. So easy peasy. How come? Let me tell you. Aluminium with nitrogen, aluminium nitride, aluminium with chlorine, aluminium chloride. Metal with negative charge always ends with IDE. Aluminium chloride, aluminium sulfide, aluminium carbide. Don't forget to write the right formula because you know the valency. That's what I can expect from you. This is great. This reaction is very important. That aluminium is a good reducing agent also. Metals are reducing agent. Why? Remember that metal believes in loss of electron. Leo, loss of electron is reduction. Gain of electron is reduction. Okay. So my metal can lose its electron and can oxidize itself. So it will lose its electron and give to other substance and other substance will take those electron and undergo reduction. Metal does reduction of other substance and itself get oxidized, okay, by loss of electron. So aluminium is a very good reducing agent and that's a very important reaction. When you put it with iron oxide powder, that's my ore also, ore of iron. And when aluminium is something that we're going to put, a kind of a displacement reaction, being a reducing agent, and going to take the position of iron. We're going to get aluminium oxide and free iron by this because of displacement and the amount of heat released in this reaction is very high and that's why it's called as thermite reaction. Why? Because of the amount of heat content released, so much so that my metal we are going to get in the molten form. Iron is having a melting point of around 1535 around this degree Celsius temperature. So very high heat content. I'm going to get a molten mixture of iron with aluminium oxide, and this reaction is also called as aluminothermy. With the help of aluminium, we are getting so much of heat content in this, and that's a reaction that we use to join the cracked machine part, join the railway track also. We'll put this mixture, molten mixture, and that will settle down, cool down, and the railway track will be joined. You got this point also? As I told you, this is important, but the most important part is my process called as Hall-Heroult's process. Yeah? Okay. So this reaction is aluminothermy. Important, important. Now just do this. Because this is the time to say that we learned total metallurgy chapter that can come to your syllabus. That is a part of your syllabus and can come to exam. Okay, awesome. Hope you get everything. I would love to see your comments in the comment section. And as I told you, how you can become a part of Vedantu, the journey is going to be awesome and you can score wonderfully well. Just take all the classes because in every class there'll be live quizzes and you'll be able to participate to make sure that you're learning, because after teaching you each and every topic, we'll take quiz to make sure that you got it, and compete with the students throughout the world. Have all the live quizzes in the replay mode also to make sure that replay won't be bored and get the maximum out of you guys. And you guys can come to leaderboard. We'll get all the handwritten notes of the master teachers so that you know what is important, where you can put more attention. All your doubts will be solved with the help of master teachers and a team of class teachers present so that no doubts will be unanswered. Come, because so many crash courses are starting each and every week so that you'll revise the entire syllabus in a quick manner. Revision is must at this moment of time to brush up your concept. And the best part is you can attend maximum classes in a very lower price if you apply this code AGE Pro with the link given in the description box for pro classes. Okay. If you'll go for 1 month subscription, 1 month is also cool to make sure that you learn all the important chapter. The pro price was 2500. It will drop to 2000. That's 2000 if you apply AGE Pro code and getting a session in as low as 10 rupees. For a long-term plan, like until your exams gets over and we make sure that each and every topic is super smooth for you, for almost 5 months you can save 40% because AG Pro code will give you the same course for 6000 and having a session in as low as 6 rupees, because you can make sure what course you want, what classes you want, and can come accordingly. Isn't it great thing? So make sure you'll come, make sure you choose the right course for you and have a right investment. Do not forget that. I am there on finally Instagram also with the ID chemistry.vedantu underscore Anubha. You can follow for all the updates and learn some topics of science, and here it will be fun as well. And do not forget to like the video, as I said, share it among your friends and subscribe if you're new. Thank you so much for staying till the last, because I know it's a big video, but students, I'm speaking continuously as well just to make sure that you can revise in approximately 1 hour the entire chapter. So please appreciate it, and you can reach out to me on my email ID. That's it for today. Leave your comments below. Thank you so much. Take care. Bye bye. Hasta la vista.